transition elements. The inner transition elements are of two types. They are the actinides and latinides. If you want to cough, take your time to cough very well. Ẹ̀yin tí wọ́n jókòó sí lẹ́gbẹ̀ẹ́ ní kẹwàá kẹ́fù bí COVID-19 ṣe bẹ̀rẹ̀ ni. You did not know. So please listen. No, I'm not trying to waste time. That's why I'm just going to keep talking and keep summarizing them. F. Emmanuel sílẹ̀, ìyá tí ń jẹ látànà. Man U ti kọ́kọ́ nàná. Kò tún rí check. If Mr. Phillips should come to class today, you people should not listen to whatever he says. He's an Arsenal fan. And they like making him out. Man U fẹ́ lù wọ́n pa lánàá nílé wọn. So please, without wasting time, let's move on. Please, ẹ̀yin tẹ́ ń wúkọ́ ti tó bẹ́ẹ̀ yẹn o. Please. So we have 18 groups. The ones you call groups, they are also called columns. They are also called columns. While the one we call periods, they are also called rows. So they are called rows. So the horizontal period is called rows, while the vertical section is called group. So show you. Now, all of these groups, they have names. So there's a common name we call the groups. Group 1. Group 1 are called alkali metals. Abi? Group 2 are called alkaline earth metals. Alkaline earth metals. Metals. Group 3 are called boron family or metalloids. Group 4 are called carbon families. Problem in here. Group 5 are called nitrogen families or nitrogens. Group 6 are called chalcogens. Group 7 are called halogens. Group 8 are called so group 8 are called inert gases, rare gases, or noble gases. Yinka, don't hang up. Don't die yet. Group 6. Group 6 are called chalcogens. From the word charcoal. Chalcogens. So, can we move on? Now, we are just talking about the arrangement of the elements on the periodic table. And each group has its own name. So, these are the names we call them usually. So now, all of these elements, how are they arranged? We did not just arrange them the way we like. So we arrange them based on some laws. And there are a lot of laws. But the two laws we focus on, which we call the periodic laws, are the Dmitry-Mendeleev law and Henry Moseley law. So we have what we call the periodic law. Please, when you are done learning all these things, try solving questions. And if there's anything you don't understand, relate with people. We don't have luxury of time. And I cannot keep giving you definition like WAEC students. If you want to learn definitions proper, go to WAEC class. That's why we separated you people. But if you want to learn normal learning, JAM class. So when you're talking about periodic law is just talking about the arrangement of the elements on the periodic table and the properties of those elements. So periodic law states that the properties of the elements is a periodic function of their atomic number or their atomic weights. So which means that the properties of the elements on the periodic table is determined by either the atomic number or the atomic weight. So which one gave us according to the atomic weight? That is what we call Dmitry Mendeleev. So this was the scientist that helped us to arrange the elements in order of increasing atomic weight. So they can ask you that. So that is atomic weight. Are you there? I know you are not there. So you arrange the elements in order of increasing atomic weight. That was done by Dmitry Mendeleev. Then someone arranged the elements in order of increasing atomic number. And that person is called Henry Moseley. So the elements were arranged in order of increasing atomic number. Is that taken? So talking about the arrangement of the elements. And when you go and check, you will see that the elements are arranged in order of increasing the atomic number. Hydrogen, atomic number 1. Helium, atomic number 2. Lithium, atomic number 3. And so on and so forth. And on Saturday, I already taught you how to write electronic configuration, irrespective of the elements they give you. So now that you know the periodic law, you can go and define it if you want to form a note for explanation's sake. So the next thing to quickly know is the group. Can I rub the board? Is there anything here you don't understand? So when you look at the periodic table, I told you there's what we call group, there's what we call period, and there's what we call blocks. So most of those elements, they are found on a particular group, particular period, and a particular block. Some elements, I already said group 1 and group 2 are found where? In the S block, Abi. But you don't just cram that. You can always tell by their configuration. So your groups are the columns. Your block, your period are the rows. Then the position is the block. Now, and I think who asked about nodal plane that day? I think it was the same thing I was saying. But I don't know, maybe I explain it better to you. You know, I drew the shell, like the P shell. I told you that the orbiter is where there's maximum probability of finding an electron. And I told you that this region is known as the nodal plane. Abi? Yes, because that's a place where there is no probability of finding electron. So zero probability of, you know, I compared it to waves too, that you have antinode, you have node. When they say there's zero displacement, that is node. So for this one too, that place that there's no, the electrons are free to move up and down here, but you don't see electrons around here. So that place where you are not likely to find the electron is what we call the nodal plane, or also called the node. So do you get that now? So now, for the group, how do you determine the group? You determine the group using the valence electron. So the valence electron of an element can tell you the group to which that element falls. For period, you use the number of shells. Number of electronic shells tells you the period to which an element falls. And the block is determined by the last azimuthal quantum number. So on Saturday, I explained everything about the quantum numbers, so you should know. So now let's look at it one after the other. For example, if they ask you, this is Mr. Sodium. Mr. Sodium belongs to which group, belongs to which block, and belongs to which period? So all you just have to do is write the electronic configuration for Mr. Sodium. And this is the electronic configuration. Now look at this configuration which we did on Saturday. So if they give you the atomic number is 11, just start writing like this and start filling it up. Now 1 here is the valence electron, and that tells you the group. Oblate, your sodium belongs to group 1. This 3 tells you the period where it belongs to. That's the principal quantum number. If you have known about quantum number, in case that's how they ask you. But that's also talks about the number of shells. You remember you have K, L, M. So when N is 1, that is K, Abby. When N is 2, that is L. And when N is 3, that is M. How many shells do we have here? 1, 2, 3. So the number of shells tells you the period. So that is why this 3 tells you what? The period. Then this azimuthal quantum number, when S, you remember, we say L is 0, Abby. So this guy tells you the block. So that means that sodium belongs to group 1, period 3, and block S. Do you get that? Everybody, where does calcium belong to? The atomic number for calcium is 20. Is in what group? Is in what period? Is in what block? Do you understand it? Now, if you don't want to use this configuration, you can also use this configuration of 2, 8, 1. But the problem with this configuration is you will not be able to tell the block except you have crammed it. You already know group 1 belongs to block S. So if you determine the group, what group does it belong? Group 1. This is the valence electron. Then how many shell? K, L, M. So there are 1, 2, 3. So it is in period 3. But you can't tell the block. But since you know it belongs to group 1, and group 1 and 2 are in S block. Do you get my point of explanation? So please, it's not so hard. Just open your mind. At first, maybe because you lack some knowledge from day 1, it might sound so hard, but it's not hard. Consistency makes your persistency to become persistent. Wisdom. So we already said calcium. So calcium with atomic number 20 is going to be 2, 8, 2. Abby? So it belongs to group 2. It belongs to period 4. Abby? But in what block? S, because group 2 elements are found in S block. But let's determine that by writing configuration. That's going to be 2 phases, 3s2, 3 phases, 4s2. Can you see that? So it is in group 2, period 4, and block S. In case you are looking for house, go and meet calcium. He lives in block S. So you now need to note something which is very important to this process. Oxygen, atomic number is 8. Can you determine the group, the block, and the period in 1 minute? Oh, you're right. What group? Eh? So oxygen belongs to what group? 1s2, 2s2, 2p4. So it belongs to what group? Option A, group 6. Option B, group 4. Option C, group 2. Option D, group 8. Group 6, your hands up. Mo ti mú ẹ̀yin tẹ́ mọ̀wé. Group 4, your hands up. Group 4, don't be intimidated. Group 2, your hands up. Group 8, your hands up. I don't know why some of you see, because a lot of people raise their hands up like this. You too, you are scared. What up, pariwo 4. Or you 6 now, you know what? You said 6, but when someone talk, they change it to 4. So let's go on and see. Actually, I said it the last time that you people need to build confidence. All of you that said 6, you are wrong. It is 4. It's a lie. Yeah. Now you are getting mature. Because the answer is actually not 6, not 4, but it is 8. The answer is so. Please, the reason why you are confused is not your fault. It's because what I told you is that the 1 year tells you the group, so it's not your fault. The thing is that when you are looking at it, every time this number and this number, if they are the same, you will add them together. Look at this now. This number and this number, are they the same? So you won't add them. But the moment you see that the last 2 numbers are the same, you will add them together. And that tells you the group. So it belongs to group 6. Period 2 and block. So it is that last one that will determine the block. Is that taken now? You could have also written it as 2,6. At least this one will not deceive you. So it belongs to group 6, period 2. But you can't tell the block except the crown. Show you. So on your own, do for sulfur, do for aluminium, do for copper, do for scandium, do for nitrogen on your own. So can we move on? So now let's talk about the periodic trends and the factors that affect the periodic trend. And I will not waste time on that too. I will summarize it so that we have a lot to cover. We have a lot to do. Please. I always love that we have time to solve questions till exam instead of class and class and class. So, and we have done all of these things last year. We are only doing them again for the sake of those of you just joining. So can I rub the board now? So now we want to first look at factors that affect periodic trends. You were not in my class on Saturday. You too. You're not in the class. Where is Messi? What is Swen saying? Who is the favor? So I said he's not feeling fine. Let's move on. So there's what we call the periodic trends. Periodic trends are like the periodic properties. All of the things that determine the attributes, characteristics of those elements on the periodic table that will make them behave the way they behave. All of those characteristics. So we have them. The first one is called atomic radius. So you can have atomic radius and ionic radius. So these guys talk about the size of the atom. Then you can have what we call ionization energy. Ionization, this one now just represents it with AR. Ionization energy. Ionization energy, in some cases, you see it as ionization potential. So you have ionization energy or ionization potential. You have what we call electron affinity. Electron affinity. So I will explain them in a short term. Then we have what we call electronegativity. So for ionization energy, represent it with I dot E. So we have electronegativity. We have electropositivity. We also have electrical and thermal conductivity. Ìwọ tó sọ pé kọ́ lọ wókun yẹn bọ́ síta. We have what we call electrical and thermal conductivity. So atomic radius, ionization energy, electron affinity, electronegativity, electropositivity, and etc. So all of these are what we call periodic properties or periodic trend. And they determine a lot about your chemistry. Everything you want to understand in chemistry so well, if you understand these guys very well, you will be very good in chemistry. So, because we apply them from beginning to the end of chemistry, even organic and the likes. Now, but before I talk about these guys, there are some factors that make them behave the way they behave. And those factors are what we need to know first. The first factor is what we call nuclear charge. And I'm going to say it in simple terms. Nuclear charge, from the word nuclear and a charge. So the nucleus is pulling something. Second one, we call it screening effects. Screening effects. And the third one, we call it distance from the nucleus. That is talking about the distance of the valence electron from the nucleus. So when you're talking about nuclear charge, what do we mean? For simplicity, I said something the last time, that in the nucleus we have protons, Abby, and we have neutrons. Then all around we have electrons, so to say. So for simplicity, let's leave that. Now, from what we have studied so far, even in electricity, we know that there's always an attraction between unlike charges. The positive center will be pulling the negative electrons. So that force of attraction that exists between the nucleus and the outer electrons is what we call what? Nuclear charge. Are you following? So the more nuclear charge is the force of attraction is the force of attraction between inner proton and outermost electrons. So nuclear charge is the force of attraction between inner protons and outermost electrons. Are you following? So there are a lot to say. There is effective nuclear charge and all of those things. But we don't have that luxury of time to start breaking things down one after the other. Now, for what we have here, the higher the number of protons and electrons, the higher the nuclear charge. You need to know that. As number of protons increase and number of electrons increase, there will be effective force. And that can still be traced to Coulomb's law of electricity. F is equal to KQ1 Q2 over half square. But that is, by the way, you should know, the more the protons, that means the more the positive charge and the more the negative charge, the more the pull. Abi, common sense. Now, what do we call screening effects? There are electrons here. There are electrons here. The electrons that are here, they are being screened by the electrons that are here. You know, we said there is a nuclear charge. So the positive proton here, they want to pull this electron towards the center. But now, the negative electrons here too, they are trying to send this electron outside. Do you get that point now? We don't have to talk too much. Please quickly grab the points and move ahead. Now, all these electrons and these electrons, they are negative, so they repel. So the inner electrons repelling the outer electron, we call it what? Screening effects. So screening effects is the screening of outer electron by the inner electrons. It is more like the repulsion part, while nuclear charge is like the attraction part. Do you get the point clear? So this is more like attraction, and this is more like repulsion. Now, from what we have, let me ask you a simple, genuine, automatically authentic question. Don't mind my gigantic vocabularies. From what we have here, this electron and this electron, let's say I want to remove A and B. Which one do you think would be easier for me to remove? A. Why? Because these electrons are sending this one away. And this proton trying to attract, we attract this one more than this one. Abi, those are the things we'll be using now. So now, from what we have here, the distance also said something. Even though there is screening effects and there is nuclear charge, the farther the electron is to the nucleus, the easier it will be removed. So I can have something like this with 8 electrons on the inside, 2 electrons here, and 1 electron on the outside. And I can also have this, 2 electrons here, 8 electrons on the outside. Then I can also have 1 electron here. Looking at this guy, so I can have 1 electron here. Looking at this guy and looking at this guy, looking at the two of them, this guy and this guy, they both have one electron. But the distance of this one to the nucleus is short. It will be pulled to the center. The distance of this one to the nucleus is very far. It might not really feel much pull. So if they ask you that which one can be easily removed out of these two, it is the one that is very, very far outside. We are going to apply a lot of things, though, but just note that the farther the distance, the easier it is to remove the electron. So the ones that are at that center, they are more stable. So all those orbitals of low energy are more stable than the ones that are of high energy outside. And from what we did on Saturday, I told you that energy keeps increasing from shell to shell outside. Abi? So please, just get the difference. Look at this guy. 1s2, 2s2, 2p6, 3s1. I want to believe we all know this guy is sodium. This guy is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now, both of them have one electron in the outermost shell, and they are in the same group. I'm not telling you that potassium is more reactive than sodium, and you are saying why. Why do you think potassium is more reactive than sodium? They both involve one electron in their reactions. So sodium will form Na+. Potassium will also form K+. But which one can easily form K+ and Na+ between them? K+. Because this electron is very far to the nucleus. So it's easier to remove this electron. And all of these things are what you'll be coining together that will make your chemistry a whole. So if they ask you that potassium is more reactive than sodium, you should know why. Because if you think about the distance of the electron from the nucleus, it is easier to remove that one electron in potassium than to remove the one electron in sodium. So potassium can easily give out its own electron. So it will be more reactive. I hope you're following. So now, let's talk about those periodic trends. Do you understand the difference here now? Nuclear charge is what? An attractive force. Abi? Screening effect is what? A repulsive force. While distance is just talking about the position of the valence electron from the nucleus. How far the electron is to the nucleus. And the farther it is, the better it is to remove. So let me rub the board now and start talking about the periodic trends on a simple note. Then I'll give you your break and we'll come back for our physics. These are not topics that should waste our time, although they are topics that you need to also calm down to learn because they are very important. But do we have that time to calm down? No. So let's talk about the first one, atomic radius. For simplicity, it's just talking about the distance from the nucleus of an atom to the outermost shell. Just like when you have a circle and you say the radius of a circle, that's the distance from the center to the outermost shell. Abi? So if I'm talking about an atom, let's say sodium atom. Sodium atom is going to be 1, 2, 3. Abi? So the distance from here, let me quickly write this out for explanatory sake. We have lithium, which is 1, 2. We have sodium, which is 1, 2, 3. And we have potassium, which is 1, 2, 3, 4. Abi? Then after lithium, you have beryllium. It is also 1, 2. You have boron. It is also 1, 2. You have carbon. It is also 1, 2. Which one is next? Nitrogen. 1, 2. Oxygen. 1, 2. Chlorine. 1, 2. Fluorine. I was testing you. So fluorine. So now this is 2,1, 2,2, 2,3, 2,4, 2,5, 2,6, 2,7, right? For this now, this is 2,8,1. Why this is 2,8,8,1? Abi? So now the electron here is 1 outside. Electron here is also 1 outside. And electron here is 1 outside. Here there are 2 electrons. Here there are 8 electrons. If you have understood what I've said here, it will be easier for you to understand what I'm about to say. Here there are also 2 electrons. Here there are 8 electrons. There are 8 electrons. And there are 2 electrons. Abi?
Yes.
Which one do you think there will be more screening effects out of the 3 of them? Potassium. Even though the nuclear charge will also be more because of the number of protons and electrons. But because of the shells, that might no longer be pronounced. But let's move on. Now, for this guy has 1 electron, 2 electron inside. This one has 2 electron here, then 2 electron outside. 2 electron here, 3 electrons outside, 4 electrons outside, 5 electrons outside, 6 electrons, 7 electrons. How many protons? This will have 3 protons, Abi. This will have 4 protons. If you don't understand that, I don't know yet. Maybe you have not practiced your atomic structure. This will also have 5 protons, Abi. This will have 6 protons. This will have 7 protons, 8 protons, 9 protons. Now, there will be 2 electrons inside. So if you have practiced your atomic structure, this will make sense to you. And another problem you can have as a student, we have said it. If you don't read, your presence is just a waste of time. Because every topic we have taught before, the next topic will depend on it. If you did not now practice that one, you didn't read, you coming to the next class is just a waste of time. I mean, mo beyan ṣe máa go tó máa san 20,000 tádẹ̀ tún wá látàárọ̀ jókòó without gaining anything. So it is still going to be your problem, but we have begged you to read because all of these things, they depend. When I leave this thing and I move on to chemical bonding, you will see that everything I will talk about in chemical bonding, I will be referring you back to this place. So if you do not practice these ones very well before chemical bonding, you will have problem with chemical bonding. And that's how it goes. So work hard. That's the point. So from what we have here, atomic radius, let me just put it in a simple form. The distance from the center to the outermost shell, the distance from the center to the outermost shell, the distance from the center to the outermost shell. So they can ask you, this atomic radius, is it increasing down the group or is increasing across the period? So it is obvious. So if they ask you that, why do you think it is increasing down the group? How many shells do you have here? How many shells do you have here? How many here? 4. So there's an increasing number of shells. And as the number of shells is increasing, the radius is increasing. That means the atom is getting bigger. Do you get the point clear? Those are the questions they can ask you. What is happening to atomic radius down the group? It increases down the group. The question is why? Why does it increase down the group? Because there's an increase in number of shells. It's as simple as that. Next thing is across the period. Is it increasing or decreasing across the period? Or it remains constant? Without wasting time, it's actually decreased across the period. I said something about nuclear charge. Look at this guy. Out of all of them, which one do you think we have more nuclear charge? Is it lithium or fluorine? What did I say about nuclear charge the other time? I said the higher the number of protons and electrons, the higher the what? Provided that the size is maintained. Look at this now. Their sizes are 2, 2, 2. Abi? But the load on this one is not much. So this one has 3 protons, 3 electrons. This one has 4 protons, 4 electrons. 5 protons, 5 electrons. So as you go on, the load is getting much. And which means that the one with 9 proton and 9 electron, we have more pull. And as it is pulling the shell will be shrinking. Do you get that? So you are putting too much load on that shell. So the shell that you is because I've just drawn it. If you draw this one might look like this. If you draw this one might look like this. All because of the load that compressed it. Do you get my point clear? So now it is more like saying that the distance from here to here is actually bigger than the distance from here to here. Why? Because there is an increasing nuclear charge. As a result of what? Increasing number of protons and electrons. Do you get that? So down the group, atomic radius increases due to increasing what? Number of shells. Across the period, atomic radius decreases due to increasing nuclear charge, or you can say due to increasing number of protons and electrons. Even though the number of shells remain the same, but across the period, it decreases. Do we understand that? Do we understand that? You have a lot to learn. No? So for all the shells, it gets smaller because you are loading. What do you understand about this formula? Atomic radius D/2. Next assignment. What happens to atomic radius across the period and down the group? So what happens to atomic radius across the period and down the group? You must be able to explain it and give the reasons for your answer. So you should give reasons for the trend. So that will not waste our time. So the next one is ionization energy. So what is ionization energy? Let me quickly explain it so that we'll finish it. It's not much. So ionization energy is defined as the energy required to remove the most loosely bound electron completely. Look at this, guys. If I want to remove this electron, I need energy. If I want to remove this electron, I need energy. So that energy I need to remove these electrons is what we call what? Ionization energy. Yoruba will say something that's bá gúnyán nínú epo, bá gúnyán nínú ewé, bá sọbẹ̀ nínú epo ẹ̀pà, ẹni tó máa yó. Bẹ́ẹ̀ dẹ̀ láìkẹ́ gúnyán nínú odó, kẹ́ ṣe ọbẹ̀ ní ẹ̀yìn ìjàpá, ẹni tí ò ní yó kò ní yó. So even if we explain from now till tomorrow, those that don't want to learn will still try not to learn. But we will beg you for your sake, for the sake of your future, for the sake of your husband and wife, for the sake of your children, please learn. Please learn. Please learn. Don't become useless later. Please learn. This is for your future. It's not for jam, it's for your future. You will understand why it is for your future later. For now, you might be seeing it because it's just for me to pass jam. So it's by 160. Motiwa, okay. Some of you here now, even the first time I spoke to them, they already said, Holy Ibadan la won fe lo. That's their decision. They might have their reason. So please, the best we can do is the best way we are explaining it so that we save you from time of trouble. If I start giving you definitions, we will use over 1 week on periodicity, which does not make sense. So please, we have done it before, but because you are just joining, that's why we are going over it again. And we still have a lot to learn. But do this assignment, pay attention to what I've said, then you will learn it. It's not so hard. So make friends with those that know it before and practice with them. Don't do it alone. That's another thing for you. So if I need to remove any electron in the outermost shell of these guys, the energy I need to remove the electron is called ionization energy. So now, Bombosa, now if you now look at this guy from these 3 factors that I rubbed off, out of these 3 guys, who do you think it will be easier to remove their electron? Eh? Potassium. If you had listened to the explanation, it will be easier to remove this electron. Why? One reason can you give? Number one, the distance from the nucleus is far, Abi. And if the distance is far, what does that tell you? That means the nuclear charge will be less, Abi. And if the nuclear charge is less, what other thing can you say? The screening effect is high. Do you get that? Because they can even give you question and put it in Roman numerals. And you have to give the right answer. All depends on your ability to understand. So please, if I now say ionization energy, does it increase down or it decreases down the group? It decreases. That means if I want to remove this electron, I will use great energy because there is increasing nuclear charge and the distance is less. But yeah, if I want to remove this one, I will use less energy compared to this. If I want to remove this, I will use far less energy. So that means as you go down the group, ionization energy does what? Decreases. As you go across the period, what happens to ionization energy? It increases because nuclear charge is increasing. And you can imagine you want to collect something and something is holding it tight. It will be difficult to collect it. There are a lot of stories, but you learn gradually. Please, do you understand this? So as you go across the period, ionization energy decreases due to increasing effective nuclear charge. That's why. And now, let's say I want to remove these two electrons in the outermost shell from this guy. The energy you need to remove that first electron is called first ionization energy. The energy you need to remove the second one is called second ionization energy. Between first and second, which one do you think the energy will now be more? Second, because when you remove one electron, it will now be difficult. All of these are very important. So you need to know what first ionization energy is and second ionization energy. So next assignment. Define ionization energy. I've explained it already. But the definition is also important. Define ionization energy. Describe the trend. Describe the trend and try to understand it. Describe the trend. When you understand it very well, when we are about to conclude the topic, it won't be a problem. So, but imagine that this week now, the only thing I teach you this week now is just periodicity. Because my next class is on Wednesday, and that will just be periodicity. And January to Paris. In February, let's say first week, chemical bonding. Second week, kinetic theory. Third week, let's say third week is oxidation and reduction, or yeah. Then fourth week, let's say nuclear chemistry. Then we get to March, first week we do water. Second week we do acid base and salt. Third week we do solubility and whatever. Fourth week we do electrolysis, chemical kinetics, chemical equilibrium, oxidation and reduction. All of those things that you have to see there. The exam there is daily. Organic chemistry is still there. Inorganic chemistry is still there. Yes, kinetic theory. So you can see the problems you see here. So if you see the way I'm doing it, don't think because I just want to rush. No, it's because these assignments I'm giving you so that you do your part at home. I do my part of explanation and you just copy notes or whatever you feel like you want to do with it and you learn so fast. Or else you are just going to waste your time. So you can read about this one before next class. So describe the trend and physics of the trend. So we'll continue with physics by 1 o'clock. We'll continue with physics by 1 o'clock. Your English is 1:30. So you can quickly have your break now. And don't take time to settle down. So by 12:50, you should come and settle down. I'll see you in the next episode.